Hello students, welcome you all to the session. So here we are going to discuss the AIET 1 NEET solutions of chemistry from class 11. Okay. So here I have taken some questions for you, the very important questions and the questions which you feel very difficult. Okay. So let's go one by one. The first question for this session is to you on the screen. And the question says that the maximum number of electrons that can be accommodated in a quantum shell is. So here it is actually a formula based question from quantum numbers. Okay. And the answer is actually 2n square. Okay. Like for example, for K shell, if I take, we have different shells, right? K shell is the first shell, okay, in which the electron is present. So for K shell, n is equal to 1. If n is equal to 1, then I will have 2 into 1 square. So it will be equal to 2 electrons. Okay. So in K shell, I can put only 2 electrons. Got it? Like if I take L shell, which is the second shell, so second shell means n value will be equal to 2. So in that case, if I substitute n value as 2, I will get 2 into 2 square, which will be equal to 8 electrons. Okay, in the same way, I can go for M. For M shell, n value will be equal to 3. And I can substitute 3, and 3 square will be 9. 9 into 2 will be 18 electrons. So 2, 8, 18. So the number of electrons goes like this for the respective shells. Okay. So the maximum number of electrons that can be accommodated in a quantum shell is calculated using the formula 2n square. Okay. Fine. Now let's go for the next question. Yeah, the next is question number 54. The element has an atomic number of 13 and a mass number of 27. How many electrons will it have in its valence shell? So from the question, it is given like the atomic number is 13 and the mass number is 27. Atomic number is denoted by the letter Z and the mass number is denoted by the letter A. So the electronic configuration will be equal to, since the atomic number is 30, electronic configuration will be 1s2, 2s2, 2p6, 3s2, and 3p1. Okay. So here you can see that the electrons are filled in the 3 shells. Okay. So whereas we have 1s and 2s2p and 3s3p. So valence shell means the outermost shell. Okay. So outermost shell is the third shell. And the number of electrons present in this third shell is 3. Got it? So the valence electrons in this atom is equal to 3. So option C is the correct answer for this. Got it? So the number of electrons present in outermost shell or valence shell is 3. Got it? So coming to next question. Question number 57 of your question paper. Which orbital has 2 angular nodal planes? So to find out the nodal planes, to find out the angular nodal planes, we have one formula. So the nodal planes is always called as angular nodal planes, or I can call this as angular nodes also. Okay. So we have 2 nodes actually. One is radial nodes and the other one is angular node. Okay. I will give you the formula for both, but here in this question, we are asked to find out only the angular nodal planes, means the angular nodes we have to find out. Got it? Means the orbital which has 2 angular nodes that we have to find out. Okay. So the number of radial nodes can be calculated using number of radial nodes can be calculated using n minus L minus 1 formula. Okay. And the number of angular nodes can be calculated using one formula, and it will be equal to L. Okay. So now we have to find out which option has the value of L as 2. Okay, which option has the value of L as 2. Okay, because the angular nodal plane is 2. So angular node is nothing but the value of L. And here L is the azimuthal quantum number and N is the principal quantum number. Okay, the azimuthal quantum number L will be equal to 0 for S orbital and it will be equal to 1 for P orbital. It is equal to 2 for D orbital and it is equal to 3 for F orbital. Now you can see 2 angular nodes means L value is coming out to be 2. So for which orbital L value is equal to 2? For D orbital. So from the given 4 options, option C is having the D orbital. So that is having the 2 angular nodal planes. Okay. So option C is the correct answer for this question. Very easy, right? But it is very important. Okay. Now moving on to the next question. Question number 59. When the azimuthal quantum number has the value of 2, the number of orbitals possible are. So now azimuthal quantum number value is given. We have to find out the number of possible orbitals. Okay. So coming to the number of orbitals in subshell, can be calculated using one formula. From the total values of M, we can find out. And the total values of M will be equal to 2 into L plus 1. Okay. 2 into L plus 1. And here in the question, it says that azimuthal quantum number has the value of 2. And here L is the azimuthal quantum number. L is the azimuthal quantum number and M is the magnetic quantum number. Okay. Magnetic quantum number. Now, if I substitute the azimuthal quantum number value as 2 in this formula, what I will get? M is equal to 2 into 2 plus 1, which it is equal to 5. So M value is equal to 5. So the number of possible orbitals can be calculated by using the values, total values of M, and that is coming out to be 5 by using the formula 2L plus 1. So option D is the correct answer for this question. Okay. Yes. Now moving on to question number 60. The correct order of increasing energy of orbitals is. So we have 4 orbitals arranged in different sets, right? So we have to find out the correct order of increasing energy of orbital. So for this, we need to find out the n plus value for all the 4 orbitals given in 4 options. Okay, we have only 4 orbitals. So let me go one by one. So first I'll take 6s. So in 6s orbital, if you see, the n value is equal to 6 and the L value is equal to 0, because in the previous question we have seen, right, L is equal to 0 for s orbital and it is equal to 1 for p orbital, it is equal to 2 for d orbital and it is equal to 3 for f orbital. So if the orbital is yes, then L value will be equal to 6. So now n plus L value is coming out to be 6. Okay. Then coming to 5d orbital, n value is 5 and the L value will be 2 for D. So 5 plus 2 is 7. Next coming to 5p orbital, n value is 5 and the L value is equal to 1. Okay, for p orbital L value is equal to 1. So 5 plus 1 is 6. Got it? Then coming to the last orbital, which is 4f. So n is equal to 4 and L is equal to 3. So 4 plus 3 is 7. So these are the n plus L values for the given 4 orbitals. Now, how to find out the increasing energy order using this n plus L value? So for that, I'll tell you one thing. If n plus L value is greater, then energy is also greater. Okay. So we have two orbitals having n plus L value as 6 and two orbitals having n plus L value as 7. Okay, the one which is having the highest n plus L value will have the highest energy. So first we have to look into the 5D and 4F. Now, among 5D and 4F, how to find out which is higher in energy? So for that, what you have to do, you have to check for the n value. Okay, if n plus L value is same, if n plus L value is same, then the one which is having n value as greater will have the highest energy value. Got it? The one which is having the highest n value will be higher in energy. Now, if I compare 5D and 4F, so 5 is greater in number compared to 4, right? So, obviously, 5D orbital will be higher in energy compared to all others. Then comes 4F. Then if you check for the other two, the one which is having n plus L value as 6, 6s is having the highest value of L, highest value of n. So obviously 6s will come before 4f and the one which is very least in energy is 5p. Okay, so this is the correct order of increasing energy for the atomic orbitals. Okay, so it is given in option B. So option B is the correct answer for this question. Got it? Now moving on to the next question. Moving on to the next question. It is question number 62. So the number of photons of light having wave number x in 2 joule of energy sources. So we know that E is equal to N into H into nu, right? So H nu is the number of photons. Okay. And we know that nu is equal to C by lambda. So what I can do in place of nu, I can substitute C by lambda. So I will have NHC by lambda. Okay. And also we know 1 by lambda is equal to nu bar. Okay. So instead of this 1 by lambda, I can substitute nu bar. So from that I will get NHC into nu bar. Nu bar is the wave number. Okay. And from the question, as the energy value is given as 2 joule, therefore in place of energy, so from this equation what we got? We got energy is equal to NHC lambda, sorry, nu bar, right? E is equal to NHC into nu bar. Okay. So let me take this. So now in this formula, I have to substitute the E value as 2. So therefore 2 is equal to N into HC into nu bar. Okay. But we are asked to find out the number of photons of light. Means the N value we have to find out. So therefore N is equal to 2 divided by HC into nu bar. Okay. So which is equal to 2 divided by HC into X. Okay, because wave number is given here as x. So nu is the wave number. Instead of putting mu bar is the wave number. So instead of putting mu bar, I have put x in that place. Okay, so n is coming out to be 2 divided by h into c into x. So in which option it is given? It is given in option C. Option C is the correct answer for this question. Okay. Now coming to question number 63. The wave number of the spectral line in the emission spectrum of hydrogen will be equal to 8 by 9 times the Rydberg constant if the electron jumps from. So, according to Rydberg's formula, nu bar is equal to R into 1 by N1 square minus 1 by N2 square into Z square. Okay. R is the Rydberg constant. Z is the atomic number. Okay. N1 and N2 are the initial and final values. Got it. Now, in the question, the wave number of the spectral line, it is given as 8 by 9 times the Rydberg constant. Now, if nu bar, which is wave number, if it is equal to 8 by 9 into R, then obviously N1 value will be equal to 1 and N2 value will be equal to 3. Okay. So let me substitute these values in this formula and then I will show you how it is coming as 8 by 9 R. Okay. That is nu bar is equal to R into 1 by, substitute N1 value as 1 and N2 value as 3 square, and the Z value is 1 because it is for hydrogen atom, right? The atomic number of hydrogen is 1. So it is 1 square. Got it? So here if we take the LCM, we'll get R into 9 minus 1 by 9. So which is equal to 8 by 9 into R. So on substituting N1 value as 1 and N2 value as 3, I am getting the nu bar value, that is wave number value as 8 by 9 into R. Okay. So if it has to have, if the wave number has to have 8 by 9 R value, then the electron must have been jumped from n is equal to 1 to n is equal to 3. Got it? Yeah. Now coming to the next question, question number 67. The total number of lines emitted in infrared region when electron de-excited from 5th excited state to ground state in hydrogen atom is. So there is an electron. It is getting de-excited from 5th excited state to ground state. Okay. And the lines are getting emitted in the infrared region and we have to find out the total number of lines emitted in that region. Okay. So let me take the diagram. Suppose if this is n is equal to 1. This is n is equal to 1. And this is n is equal to 2. Here it is 3. And this is n is equal to 4. And this is n is equal to 5. And this is n is equal to 6. Okay. So N1 is the ground state. And this is the first excited state. If an electron is present here, it is the first excited state. And this is the second excited state. This is the third excited state. This is the fourth excited state. And this is the fifth excited state. Okay. Now, de-excitation is happening. Okay, means from the fifth excited state, it is coming to the ground state. Okay. So, if an electron is present in n is equal to 6, it can come from n is equal to 6 to n is equal to 3. n is equal to 5 first, and it can come from n is equal to 6 to n is equal to 4, and it can come from n is equal to 6 to n is equal to 3. Or we can move electron from n is equal to 5 to 4 or 5 to 3. Okay? Or it can come from n is equal to 4 to n is equal to 3. Okay? Got it? So what are the possible transition? N is equal to 6 to n is equal to 5, n is equal to 6 to 4, n is equal to 6 to 3, and n is equal to 5 to 4, n is equal to 5 to 3, and n is equal to 4 to 3. Okay? So now you can see that 6 lines are emitted when an electron de-excited from fifth excited state to ground state for an hydrogen atom. So we are getting the total of 6 lines emitted from this region for this electron. Okay. So the answer is equal to 6. Option D. Okay. Answer is 6 and the correct option is D. Got it? Okay. Now moving on to the next question. Question number 69. The correct set of 4 quantum numbers for the valence electron of rubidium atom is. So, to find out the 4 set of quantum numbers, we need to find out, or we need to know the electronic configuration, at least the outer electronic configuration of rubidium atom, whose atomic number is 37. Okay. So, rubidium has the outer electronic configuration as krypton, noble gas with 5s1 configuration. Okay. And here you can see that n is equal to 5. Okay. The valence electron is present in 5s orbital. Valence electron means the last electron of rubidium atom. It is present in the 5s orbital. So we are asked to find out the quantum numbers for the valence electron. So n value is equal to 5 since it is a 5s orbital. And if n is equal to 5, and if we have the orbital as s, we have already seen now L is equal to 0 for s orbital, 1 for p orbital, 2 for d orbital, etc. So since the orbital is s, L value will be equal to 0. Got it? If L is equal to 0, then M value can be found out using minus L to plus L formula. Okay. L is already 0. So M will be from minus L to plus L means it is minus 0 to plus 0, which is again equal to 0. Okay. So M value is also equal to 0. And S is the spin quantum number. And it will be equal to plus half or minus half. Will be equal to plus half or minus half. We can have anything. So we have N is equal to 5. L is equal to 0. M is equal to 0, S is equal to plus half or minus half in equation in option A. Okay. So option A is the correct answer for this question. Got it? So in option A, we have the set of quantum numbers. Got it? Now coming to question number 70. Which of the following does not contain number of neutrons equal to that of argon 18 point? So how to find out the number of neutrons? We have one formula, right? Number of neutrons can be calculated using mass number, which is represented as A, minus atomic number. Mass number minus atomic number formula. Okay. And for argon, atomic number is 18 and the mass number is 40. So if I calculate the number of neutrons for argon, it is 40 minus 18. It will be equal to 22 neutrons. It will be equal to 22 neutrons. Now we have to check for the option which has 22 neutrons. So what about for potassium? So potassium is having 41 minus 19, which is equal to 22 neutrons. Okay. Then coming to scandium, option B, which has atomic number 21 and mass number 43. The mass number is 43, atomic number is 21. So if I subtract this, I will get 22 as the value again. So option B also has 22 neutrons. And if I go for option C, scandium 21 and 40, mass number minus atomic number is giving 19 neutrons. So option C is the answer, right? Because it does not contain the equal number of neutrons to that of argon. Okay, it is an exceptional case here. So option C is the correct answer for this question. We can also check with option D. Option D, we have calcium. Okay, calcium with atomic number 20 and mass number 42. So if we substitute for subtract 42 and 20, we will get 22 neutrons. Okay, so option C is not having the number of neutrons equal to that of argon 4018. Okay. Next, coming to question number 73. Calculate the energy associated with photon of light having a wavelength 6000 angstrom, and H value is also given. So we have to find out the energy value. Okay. So we know that E is equal to H into nu. Or nu is equal to C by lambda. So E is equal to H into C by lambda. H value is given in the question. H is given in the question. And the C value is nothing but the speed of light. Okay, speed of light is 3 into 10 to the power 8 meter per second. But in terms of centimeter, it is 3 into 10 to the power 10 centimeter per second. And the lambda value is also given in the question as 6000 angstrom. So 6000 angstrom. So 1 angstrom is equal to 10 to the power minus 10 meter. So if I convert this into centimeter, it will be 1 angstrom is equal to 10 to the power minus 8 centimeter. So instead of this, I can write 6000 into 10 to the power minus 8 centimeter. Okay, now I can substitute all these values here in this formula. Therefore, E will be equal to H 6.624 into 10 to the power minus 27 energy second into C value, which is 3 into 10 to the power 10 divided by lambda value, which is 6 into 10 to the power minus 5, I can keep, right? 6 into 10 to the power minus 5 or 6000 into 10 to the power minus 8. I can keep as such also. Now, if I substitute, if I multiply and if I divide, I will get the final answer as 3.312 into 10 to the power minus 12 energy. Okay. So where it is given? It is given in option C. So option C is the correct answer. Just the substitution and the E is equal to HC by lambda formula. Okay. Just you have to be very careful with the units. Here I have calculated using centimeter. You have to be very careful with the units. Got it? Now coming to the next question, question number 77. A helium molecule is moving with the velocity of 2 into 2.40 into 10 to the power 2 meter per second at 300 Kelvin. The de Broglie wavelength is about. So what is de Broglie wavelength? It is lambda. So we are asked to calculate the lambda value and the velocity is given, temperature is given. So now let me write the given value first. Velocity is equal to 2.4 into 10 to the power 2 meter per second, which is actually equal to 240 meter per second. Okay. And to find out the wavelength, the formula is h by mv. So this is the formula which we have to use. This is the de Broglie formula. Okay. H is the Planck's constant. Velocity is given in the question and we don't know the mass. Okay. So we have to calculate it. So what is the mass of one helium atom? Mass of one helium atom is equal to, the atomic mass of helium is 4. Okay. And for one helium atom, it is into 1.66 into 10 to the power minus 27 kilogram. So I will get the answer as 6.64 into 10 to the power minus 27 kilogram. So this is the mass of one helium atom. So I have the mass value, I have the velocity, and I know what is h. I can substitute everything and I can get the answer. So since lambda is equal to h by mv, lambda is equal to 6.626 into 10 to the power minus 34 divided by 6.64 into 10 to the power minus 27 into 240. Okay. It will be equal to 0.004141 into 10 to the power minus 7 meter. So it is equal to 4.141 into 10 to the power minus 10 meter. Okay. And 1 meter is equal to 10 to the power minus 9 nanometer. Okay. 1 meter is equal to 10 to the power minus 9 nanometer. So here I can put this value in terms of nanometer and here I will get the lambda value as 0.414 nanometer. Okay. So I have 0.416 nanometer in option A. So that is the correct answer. Okay. Now coming to the next question. Question number 79. 1 gram of hydrogen contains 6 into 10 to the power 23 atoms. The atomic weight of helium is 4. It follows the number of atoms in 1 gram of helium is. So we are asked to find out the number of atoms. To find out the number of atoms, we have to use the number of moles formula. Number of moles is equal to number of atoms divided by Avogadro number, right? So let me take number of atoms as n. So we are asked to find out the value of n. So n is equal to number of moles, which is represented as small n, into Avogadro number. Okay. But number of moles value is not given to us. So what we have to do? We have to take the formula to find out the number of moles. Number of moles can be calculated using one more formula, which is equal to the given mass divided by molar mass. So the given mass of hydrogen atom is 1 and the molar mass of hydrogen is, the mass of helium is 1, and the molar mass is nothing but the atomic weight, okay? It is equal to 4. So in place of number of moles, I can substitute 1 by 4, and the Avogadro number is 6.02 into 10 to the power 23. So this is the number of atoms, okay, in 1 gram of helium. So it is given in option A. So option A is the correct answer for this question. Okay. Then the next question, question number 80 is the empirical formula of a compound of molecular mass 120 is CH2O. The molecular formula of the compound is. So we have the the empirical formula of the compound as CH2O. Okay. So CH2O has the mass as, okay, let's calculate the mass. So carbon atomic mass is 12. Carbon atomic mass is 12. And for hydrogen, it is 1. Since we have 2 hydrogen, it is 2 into 1. So it will be equal to 2. And for oxygen, the atomic mass is 16. Now, if I add everything, like 12 plus 2 plus 16, I will get 30 grams. Okay. So the empirical formula has the mass value as 30 gram, and the molecular mass is given as 120 gram per mole. Molecular mass is equal to 120 gram per mole, means it is 4 times the 30. 120 is the 4 into 30 is 120. So which is 120 gram per mole, which is 4 times 30, right? So what we have to do? We have to multiply this empirical formula by 4. Means the molecular formula is equal to C4H8O4. Okay, multiply each atom by 4. So 1 carbon is there, so 1 into 4, 2 hydrogen, 2 into 4, and 1 oxygen, 1 into 4. Okay. So C4H8O4 is the molecular formula for the given question. Option B is the answer for this question. Got it? Now next, coming to question number 84. If the atomic mass of sodium is 23, the number of moles in 46 gram of sodium is. Very easy, right? We are asked to find out the number of moles. So to find out the number of moles, we need mass and molar mass, right? So we have the atomic mass value as 23. Okay, and the given mass of sodium as 46. So the given mass is equal to 46 gram, and the molar mass or the atomic mass of sodium is equal to 23. So we can substitute in the number of moles formula. Therefore, number of moles is equal to the given mass divided by molar mass. So it is 46 divided by 23, so which is equal to 2. Okay, so very easy. Option B is the correct answer. Option B is the correct answer for this question. Okay. Then coming to question number 85. 16 gram of an ideal gas SOX occupies 5.6 liter at STP. The value of X is. Okay. At STP, the number of moles can be calculated using given volume divided by 22.4. Okay. So at STP, the number of moles can be calculated using the formula, which is given volume divided by 22.4. And also we know that number of moles is equal to mass by molar mass. It is also the formula, right? Yeah. Now we can substitute and equate this. The given volume is 5.6 by 22.4 and the mass is given as 16 gram for this gas and the molar mass we have to find out by cross multiplication. Okay, so if we cross multiply, we will get the molar mass value as 64. We get the molar mass value as 64. Now, we are asked to find out the value of this x. Okay, in SOX, we have to find out x. We know the sulfur mass as 32. Okay, plus we need to find out x and the atomic mass of oxygen is 16. So x into 16. So if we add these two, we have to get 64 as the molar mass value. Okay. So sum of the atomic masses will give the molecular mass and the molecular mass is 64. We need to find out the value of x. Now on solving this, we will get the x value as 2. So the given gas is sulfur dioxide. Okay. Value of x is 2. So option B is the correct answer for this question. Okay. Now moving on to question number 98. How many moles of magnesium phosphate will contain 0.25 mole of oxygen atoms? So again, we have to find out the number of moles of magnesium phosphate. Okay. 8 mole of oxygen atoms are in 1 mole of this magnesium phosphate, right? Because you see the oxygen count 4 into 2, we have 8 oxygen. So since 8 mole of oxygen atoms are present in 1 mole of this magnesium phosphate, Mg3PO4 twice, 0.25 mole of oxygen. Therefore, 0.25 mole of oxygen atoms will have 1 by 8 into 0.25 mole of magnesium phosphate. Right? Just the cross multiplication. So 8 mole of oxygen is in 1 mole of the compound. 0.25 mole of oxygen will be present in 1 by 8 into 0.25. Okay. So this will give the value as 3.125 into 10 to the power minus 2 mole of magnesium phosphate. Okay. Just the cross multiplication. Got it? Suppose if they are asking you to find out for phosphorus, how many phosphorus we have in this? How many moles of phosphorus? We have 2 moles. Because it is 1 into 2. What we need to do? It is 2 mole of phosphorus atoms are in 1 mole of magnesium phosphate. 0.25 mole of phosphorus atom will be present in 1 by 2 into 0.25. Are you getting? Then the same way for other atoms also. Clear? For magnesium, it is 3. 1 by 3 into 0.25. So according to the mole value, according to the moles of the corresponding atoms, we have to get it by doing the cross multiplication like this. Got it? It's very easy only. Next, moving on to question number 99. If 30 ml of hydrogen and 20 ml of oxygen reacts to form water at same temperature and pressure, what is left at the end of the reaction? So actually, this hydrogen reacting with oxygen will lead to the formation of water here. Okay. So H2 plus half O2 will give H2. Okay. So this is the balanced chemical equation for the given question. Okay. And here we have the number of moles of hydrogen as 1 and the number of moles of oxygen as 1 by 2. Okay. And from the given question, 30 ml of hydrogen is reacting. Means half of the oxygen, half of hydrogen's volume is reacting with oxygen. Okay, half of the T. So it is 1:1/2 ratio, right? So 1/2 of this will be 15. So 30 ml of hydrogen would have got reacted with 15 ml of oxygen because it is in accordance with the ratio. Clear? But we have 20 ml of oxygen in the reaction mixture. Okay. So therefore, oxygen left in the reaction is equal to, we have 20 ml, out of which only 15 got reacted with hydrogen, okay, with a half mole of it. So the remaining oxygen will be 20 minus 15, which is equal to 5 ml. So 5 ml of oxygen is left at the end of the reaction. Okay. So option D is the correct answer for this question. We have 20 ml of oxygen, but only 15 has got reacted because the ratio is just the half of the hydrogen value. Got it? Very easy. Now moving on to the last question for this session. Which of the following statements is incorrect? So we have 3 statements and with the none of the above options. So let's check one by one. Option A says that 1 mole always contains 6.022 into 10 to the power 23 entities. Yeah. So 1 mole is equal to the Avogadro number of entity. That is correct. 12 gram of the carbon-12 isotope contain 1 mole carbon atom. Yeah. In 1 mole of carbon atom, we have 12 gram of the carbon-12 isotope. So that is a definition for 1 mole. That is also correct. And in option C, we have 1 AMU is the mass of 1 mole of hydrogen atom. Okay. The mass of 1 mole of hydrogen atom is 1 gram, right? Not 1 AMU. The mass of 1 mole of hydrogen atom is 1 gram and not 1 AMU. Okay, it is actually 1 gram, not 1 AMU. So option C is the incorrect statement, which is the correct answer for this question. None of the above is not the answer. Okay, so this is how we have to find out the incorrect statement from this question. And with this, we are wrapping up this session. And thank you so much for listening to the lecture. And I hope this lecture finds you well for solving many questions which you feel it very difficult. Okay. So meet you all with the next set of questions in the next session. Till then, take care. Bye-bye.